I'm talking about how Python has got better for Samba. And I'm generally trying not to talk about new language features because we can't use them for years and years and years and years. I'm talking about how it's got better for developers. There's tools and instrumentation that improve our lives. So let's see if I can make this work. Okay. And I'm not going to talk about much because it's only half an hour and it's the middle of the night here. So the history of Python and Samba is, well, the old history, I won't go into that. But in recent years, we've made the transition from Python 2, supporting as far back as Python 2.6. And we've kind of jumped over the mountain of into Python 3 land. And while we were making that leap, there were a lot of things that we couldn't use in Python 3 because we also were supporting Python 2. But now that we've really kind of landed, we're almost fully in Python 3. We still have 4.10 users supports Python 2, but that's going out of support in a few months. There are new things we can use. So I'm talking about the things developers use rather than things that we are actually putting into the code, because I don't want to I don't want people to be putting new features in, as I was saying. That won't work on the oldest Python. So my target is for this talk is Python 3.7, which happens to be the Python I have on my laptop, and that's what you get in Debian stable. We have to support 3.4 in backports, and the latest Ubuntu and Fedora will have 3.8. But anyway, so here's an example of a thing that's got better in Python. So with valgrind, if you run Python under valgrind, even when you're doing nothing, now in this line here, that -c with an empty string, that's running Python and asking it to run an empty program. So it's not doing anything. And what valgrind does when it sees that is it writes about 7,000 lines of noise, because Python has its own malik, which it knows how to understand. It knows where it can walk around and read out of the allocated memory safely, because it's a special malik that it knows the size of a Python object and all this kind of stuff. But valgrind doesn't know what's going on, and so it gives you all of this. But since recently, since Python 3.6, if you put this environment variable before you run it, so that's just Python malik equals malik. This is the same line, Python 3-c with the empty string. It finds that in fact there's nothing wrong there, and that slows down Python by about 10%. But it just means that all those mysterious sig faults that you could never work out in the Python bindings, because valgrind gave you 100,000 lines. Well, Now that no longer happens. So that's since 3.6. There are other arguments to Python Malik. You can ask it this environment variable. You can ask it to debug as it goes along, which is what it does. It's kind of puts magic values around the allocations. You know, where it shouldn't step and where it that kind of thing, and where it can step. So then, when something is overwritten, it knows, and then it can complain. The standard kind of stuff that people do. And then it runs this module TraceMilic when it finds something wrong. And TraceMilic is another new thing. So you can run TraceMilic if you choose by using this another environment variable, or you can do this -x TraceMilic, and that asks Python to trace where its allocations have come from, and that the -i there just says, where it says run this thing and then drop into a shell so that we can look at what has been going on, which in fact is a little bit uninteresting because unless you really have got problems at the end of your script, you probably want to know what somewhere in the middle where things have gone wrong. But this is an example. So running the background Samba tool help, and then when it's finished, it just drops into the Python shell, and then you can ask Python what Samba tool did, where the allocations were and stuff like that. And then this example is just showing the top 3 largest allocations, which isn't very big, probably because everything, these are basically the things in the global scope, the things that were built up, and then now they've been collected by the garbage collector, and they're all gone again. So there's nothing really left. It's just kind of things that were left in the global scope. So I haven't actually found a use for TraceMatic, but I can imagine it would be. And now, of course, it doesn't find anything that isn't a Python allocation. So it doesn't find talic allocations. Although, because we tie the talic and the Python together, they're related. And if you give it a number, you can it'll give you a longer distinguishing line about. Here we've got just the one line saying where it came from. If you give it 10, it'll give you a traceback of how that came about. Okay, now here's a more useful thing. It's a kind of shouldn't be more useful, because it's equivalent. Breakpoint is equivalent to these 2 lines, which you can always do is import PDB and PDB set trace, except it's really quite hard, even if you'd been doing it for a long time, to remember exactly how to spell that. Because I could never remember whether there was an underscore there, or even why set trace was the word. Now, so there's a new built-in function, like a top-level function. It's always there, breakpoint, and that just breaks you into PDB, which is it's like GDB. So it's like in the C code you can write Samba start debugger, and it starts up an X term. This just stops the Python script wherever you are, and you can look about what's in and see what's in there, and then you can and so you can all the things you do in GDB, you can do in PDB, or most of them, except of course it's not C level, it's Python level, and you can also run Python stuff there and look at the Python tracebacks and stuff, and you can also, this is another new thing, you can drop into the full interactive Python shell, which is really quite useful if you are trying to poke around and see what is there. You don't need to write P before each thing, and you don't need to worry about whether your expression is a Python. Your Python expression is also a PDB expression. So a similar problem, at least I have in GDB, is you can write expressions that are C expressions in GDB, but there are some things you just can't do, and the boundary of what you can and can't do isn't clear. But in the interactive shell, and as in pure Python, you can do anything except the shell isn't empty. It's at that point in the program where you break the breakpoint. So you have everything, all the local variables and all the global and everything is just there. And this just makes debugging Python much nicer than it was when you had to write the 2 lines. And you can do things like dropping into the interactive shell. And now you can also, with another environment variable, you can change your breakpoint from being BDB set trace to something of your own. This samba.debug.breakpoint is fictional, I think. I didn't actually look, but you could make a breakpoint that when you write so you put breakpoint in your program, you can't find the problem with your and at the Python level, and then you can just, without changing where your breakpoints, you just point with the environment variable, you point to one that you've written that starts GDB at that point, or does something else. So you can change your tools without changing your program if you have written them already, which I haven't done. So probably breakpoint is one of the greatest new things in Python 3. Like all that rubbish about Unicode and stuff. That's a lot of things changed, but okay, I'll go back and what they did with Python 3 is they changed so many things that just annoyed people so much that they got to a point like 3.4 or something where they made a moratorium on adding new features because it was annoying people, and they just tried to make things nicer for developers, and that's what all this has come out of. That it kind of changed the focus from ruining things for us by making incompatible changes to making our lives better. And so now we are okay. This is like the payback. We leapt over the wall into Python 3 and landed in on cold hard concrete, and but now they're kind of making it nice for us. And another one here, fault handler, which is just what SMB panic, default SMB panic, it gives you traceback. Well, if you go -x fault handler, it'll do that for Python, but again, it does it in the Python scope. So you don't get the C traceback, which would be useful to also have. You get the Python one, which is good. And I don't know if there's a way to change the fault handler like you can with SMB panels. I haven't seen anything. I guess you'd have to look at, see how they do it and see if there's a just a dashv. It just tells you where it found the modules. It's one thing that is verbose, I guess, but that's what it does. And then it was 2 V's. It just tells you where it wanted to find the modules, but it didn't find them. So this is if you happen to have a system LDB on your, and sometimes Samba tool does something strange. Maybe it has found the system LDB instead of your development one. That's the kind of thing that this could be useful for. So I haven't actually used it. Have fairly good use for it. This Python hash seed, we use this in some places just to reproduce the now there's a randomized hashing algorithm, and that means that you never get the same result if you're using a hash. I mean a dictionary. Well, actually, sometimes you do, but you do more. This makes it so you always do. And you can, there's another option, -x UTF-8, to ensure that you're also always using UTF-8, regardless of the locale, which I think could be useful sometimes for when we're trying to ensure things is a constant in the tests or something, maybe. There's another -x thing, import time. It just tells you, this is new in 3.7, it tells you how long it took to import things and what got imported. And it's actually quite interesting. I ran it on, well, I need to go up to the top of that. This line, just that -c means run this program. And that, so importing Samba, it ends up importing all of this. Now, these are microseconds, and if you look at, say, this line encodings, that cumulative is the sum of all the things that are indented above it until we get up to that one. So those 3 things and encodings itself add up to 2 milliseconds. Now, all the ones above this line site, that's just what Python does. It's part of Python's startup, and we can't change that. So that's 17 milliseconds. I mean, we can change it. You can change it on your machine by fiddling with your setup, but you shouldn't. You can't change it for anyone else. But what happens in what Samba imports? Just remember, this is just importing the Samba module. It starts importing things like URL and the regular expressions in enum. I don't know what that's for, and then base 64 email, all these hash functions and email errors and HTTP and more and more and more and more. You encoding email message and a whole lot of stuff. So that's all part of a HTTP client, all of that, and temp file. So that's all seems to be part of URL lib.request, and all of, so that's, and all of that comes from these URL lib. So I thought I'd look into why we were doing this, and it comes from this module here, Samba compat, which is like a wrapper around what is different between Python 2 and Python 3, which we don't really need anymore. We've been keeping it around because we don't want to be mean to ourselves when we're backporting. But now with 14 going away, this can start going away. So to paraphrase that, it imports these modules. It actually imports more stuff from it than this lib quote, but this is the one that is used. So it's getting one function. One function is used from here by one file. So one file. So in all of Samba Python, which is hundreds of thousands of files, there's one of them that needs this URL lib quote, and because our way of easing into Python 3 was to put everything like that into compat. We made everybody who imports Samba pay the cost. So they're like you know, I don't know, in a Mac test there would be many Python. Many times Python has started up. Each time we pay 35 milliseconds, and every time somebody, you know, runs Samba tool, they're paying 35 milliseconds for this provision. So, like, if we just in provision, if we rather than importing it from samba.compat, we take it out of samba.compat and put it back. Put the Python 3 one back in here, and then we save a whole lot of time. But now, so it's down. It was this number down here was 75 or something. Now it's 43. But we're still getting a whole lot of these ones, like the regular expressions and stuff, and they're coming from socket server. So I thought I'd look and see. Socket server is, so Samba compat is still 11 milliseconds, and socket server is 9 of those. And again, it's just one file that is using socket server, and it's a test. And so if we just move the that do the same thing, move that import into that thing. Now when we import Samba, it's down to this part. Now there it is again. I don't know what those colors are for. And Samba glue is by far the slowest thing. I don't know why. It's a mystery. No, there's not. It's not a very big module. It's written in C, so you know it compiles into a few things, and that's just a few names, and then like I don't see it doing anything tricky, but it must be doing something that it makes it slow to import, and I haven't seen what. Anyway, so this Samba-X import time gives you warnings about this kind of thing, and that's new in 3.7. Now, and you also get this -w gives you warnings, and they're pretty pointless. Like here's an example. So W default is just the way of saying give me the default warnings, and it's a little script, an inline script saying open a file that does exist, but it doesn't close the file. And then so you get a resource warning saying you didn't close the file. Now, with Python, of course, the file object that gets created, and then it's not assigned in the script to anything, and so it falls out of scope as soon as it exists. And the garbage collection should, well, the reference count would go to 0, and that would be cleaned up instantly, even if the program wasn't finishing just at this point. So this kind of you get a lot of these warnings if you run the warning over real code, and it's not actually a problem. If you're doing serving sockets and stuff like that, then it is quite useful because you get to see where you might have a socket hanging and you don't quite know what the status of it is. And you can, this is just showing, you can put a 3 there or another number there to give you more lines of traceback of where it went wrong. In this case, because it's just an inline little script, there's no further information, and there's different options about how you can get those warnings. Now, if you use -xdev, you get a whole lot of these things all at once, and as the version numbers go up, they keep chucking more things into this bucket without necessarily making another way for them to be found. So it's kind of like, this is the thing, you actually just want to go Python 3 -xdev and run your Python with this and just see what happens. Now, and that also actually includes this Python asyncio debug, which with the asyncio module and there's a associated kind of keywords and stuff. This will track your coroutines and your event loops and kind of make sure that you're not doing anything that it can see is wrong. And if you have an IO that takes more than whatever it thinks the right time is, and if the callbacks takes too long, it'll give you warnings. So I think that would be really useful. I haven't actually used it, but because we don't use async IO, because we don't support. We do support older versions of Python. Then this became useful, and I'm thinking we will be using it a lot more in the future, because it would be a good it would be a good basis for making daemons that aren't necessarily high use. Like there's a thing called, what's it called? Something web services. Now I've forgotten it. But it's this thing that it's not actually a web service. It's the back end of the PowerShell commands that so like a really weird bespoke, it's pushing things over UDP kind of protocol. That and they called it web services because you need to call it something. Anyway, so we it'd be nice to have something that talked that language and on the Samba side, and then could be then and could either proxy to the things like LDAP, or else it could just import LDB and talk to the database more directly. But it wouldn't need to be performant to the same extent as the LDAP server or anything else, because it's only PowerShell users, and that's an admin who comes along every 2 weeks. But now, when I was making these slides, I thought I'm not going to talk about this stuff because I'm talking about improvements to the language. Except then, just before I started talking, I happened to look at the schedule and I read my abstract. My abstract said I was talking about this stuff. So, well, man, I've said that much. That'll do. And there are a lot more of those -x options and things if you recompile your Python with flags set, so that you can get more insight into Python's problems with its own memory management, which I don't know if we really need, and I don't think we need to. I don't need to be compiling more stuff. So I haven't looked into that. I think the reason you need to turn them on as compile time features too is that they're the more expensive ones, even when they're not turned on. Whereas these things, if you do turn it, like the most of those -x things, TraceMatic and stuff, it's almost no overhead. It's if you put everything on, it's still less than 50%. And there's more things coming in 3.9, I think. Yeah, and look, more options I haven't actually looked at. And that actually is all my slides, and I'm hoping there's some questions.
Yeah, do we have any questions? Please feel free to use the Q&A section, or you can raise your hand via the button at the bottom, and we will call upon you to state your question. Anyone? First of all, let me thank you, Douglas. As I understand, it's almost 2 o'clock in the night.
Yeah, it is. Yeah, quarter to 2.
Yeah, incredible. Thank you very much.
What I would be, of course, if I'd come to Germany, I would be awake at this time. Sitting in that big hotel. But yeah. Okay.
David has a question. Great work, Douglas. Oh no.
No, I can't. I've lost the window. I've lost my Zoom window, so I don't know where it's gone. I can't see the questions. Hang on.
So far, there are no really questions. You can check at the top of your screen. You should see the Q&A button.
Yeah, no, I don't. It's gone. My entire Zoom has gone into this tiny little column.
Okay, that's tragic. Andrew is asking, so is it time to drop the remaining compact code or compat code?
Actually, sorry. Now I do. No, I found that bit. Where? Oh, Q&A. There, I see. Oh, there it goes. Okay. So, is it time to drop the remaining compat code? Yeah. I think as we find it. I mean, we Andrew and me have talked about this before. So the reason we haven't yet is that for backports, it would make it much harder, and we have been supporting 410. But now that like these changes that I talked about in the import time thing. They can go in if we urgently need to backport something before 10. It won't actually make any difference because just taking things out of the compat and putting them into the other places. It's hardly any change, and just doing that a few times actually withers away Samba compat, so there's nothing left. So actually, I think it's going back is going to be easier. Okay, and Go Albert has got, what's the typical issue we met with Python code Samba tool? Performance issue, crash in the C code. So, both. Well, no, crashes. So Samba tool is usually not doing much on its own. It's talking to the server, and the server is often another machine. But we have, over the years, we've had quite a few memory problems between Python and Samba, and they're pretty much all sorted out now. So when it came to talking about this stuff, I thought I'd find an example where it was useful to find one, and then I realized that actually they're all gone. So we've worked out a whole lot of the problems that would have been useful for. We've worked them out already.